All right, so we're going to go ahead and get started. I appreciate everybody kind of giving us just a little bit of patience. We're still figuring out some of the streaming technology and stuff. Typically, Assad would be here to do introductions, give you updates, those kind of things. My mistake on not getting it all prepped correctly. So he is currently in attendee view and can't present with us. So I apologize for that one. We'll promise we'll get it better for next time as we continue this move into a remote only kind of environment. So we're going to go ahead and get started. I will go ahead and take over the introductions piece for Assad. Devlin Liles, I'm the president of Improving Houston, and this is just about everything you need to know about me. Passionate geek, lifelong learner, and today we're going to be talking about great architecture being easy. And what do I mean by that? I mean that great architecture should be both easy to come to, but also easy to use. And it's a fine line to manage when we're talking about applications with millions of lines of code, when we're talking about integration with hundreds of developers, dozens of different tools, maybe dozens of third-party applications and those kind of things. And so finding simplicity and elegance in an overly complicated world where technology is changing constantly is hard. It's a difficult problem, but when you find it, it just clicks. It just falls into place and it's easy. It's simple to use. And so we're going to look at a couple of case studies around technologies that have bridged that gap. Technologies who have looked into the mired chaos and seen the patterns. And they've not tried to be everything to everyone, but they've projected forward a simpler version of the world that has had great and wide and lasting effect into modern software development. We're going to use those as a pattern by which to model our decisions moving forward so that potentially we can seek that same ease and elegance that these solutions have achieved. Now, we're going to be talking about these as patterns, not as language. So whether you're dealing with the Java versions of these, or you're dealing with the Node.js versions, or if you're dealing with the .NET versions, we're going to be talking about the complexity of a problem space, not any particular solution. And so this should be broadly applicable regardless of the language you choose to exercise your architecture in. So I have to start with what I call the 4 core patterns. The 4 core patterns is a kind of running joke amongst a group of my friends in which I am of the belief that just about any problem can be solved easily if you identify the right 4 patterns to apply to it. Now, those 4 patterns are never the same. They're very situational. They're not a golden hammer, but to me, a set of guidelines to tell me to keep focus on the things that matter. Now, before I go any further, if you have questions, there's the QA piece inside the app. Feel free. I've got it up on the right-hand side over here. I've got the camera in front of me. I've got my slides off to the left. And so we've got this set up so that if you've got questions throughout, we can get as close to conversational that we would in person without us all having to wear face masks and stand in bubbles. And so if you have any questions, feel free, hit into the QA. I'll be trying to keep up with those as we go. Now, when we talk about the core patterns, one of the first questions we have to ask with applying the kind of level set of what patterns are we dealing with is what level of problem do we have? I like dividing architecture into multiple levels, and those levels can vary from kind of base level technical design all the way up to enterprise architecture, really future looking, crazy, deep stuff. There's a video out on YouTube that goes through a lot of those different levels. I can send out that link afterwards here. But what level of problem are we talking about? Is this a level of design that's going to affect the architecture that is for my team? Or is it for just this class in which I'm trying to wrestle with a complex problem inside this one implementation area? Or is this a architectural problem that's going to affect the entire solution and how we apply, let's say, user security or logging or versioning of entities? Or is this something even bigger that's going to affect how systems integrate? Is that messaging patterns and eventing patterns and integration structures and data storage, analytics, all of those? And so the first question to ask is, all right, what level of problem do I have? Because those 4 core patterns that you're going to apply are at the same level of as the problem is. So if I've got a systems integration problem, saying that I'm going to tackle it by using the adapter pattern just doesn't make sense, because the adapter pattern is a deep implementation kind of concern, maybe a solution design problem. It's not systems integration. Now, if I were to say that I'm going to use event-driven domains, or I'm going to use event store, or I'm going to use mass transit with long-running sagas, like those are different types of patterns at that systems integration level. But you've got to match the solution to the level of the problem you're dealing with. And when you do that effectively, you end up with these kind of simple, easy to follow templates of implementation that allow you to progress quickly through a whole lot of problem spaces in the code base. The second one is, the second question that drives into what are my 4 core problems are, what are the related problems? So I've got systems integration problems. Okay, well, I can integrate systems, but what's the next thing I'm going to have to deal with? Probably going to have to deal with data correlation. So this system processed a record, another system processed a different part of that record, but they're still related. They're based on the same kind of inbound user input, or, you know, I like using banking for this. A user opens a new account. There's 3 or 4 different systems that respond to that new account creation. But I need to know all of those different inputs, all of those different pieces for correlating back to go, okay, new account creation, I'm done. Here's the steps I took. These systems responded correctly. I now have a fully created account for my user inside all of these interconnected systems. So you might have a related problem of data correlation, of being able to pass information through. You might have a concurrency problem in that space of what happens if I try and create a new account, but before a system is done processing, I need an update to that account. And so now I've got concurrency, I've got a race condition. I might get the edit process through one system before the creates process through another. How do I deal with those things? You might have data validation issues. You get a user's, hey, I'd like to create an account. You've got a fraud prevention system, and the new account comes in, the fraud prevention system shuts it down. It goes, nope, this person's created 100 accounts in the last few days. They're just trying to get the free incentives. But do my other systems keep responding and setting up that account for them? Or does the fraud prevention system have the ability to intervene in that long-running integration? And so you've got to identify the related problems. Some of the best, worst decisions I've ever made have been when I solved the core problem and I ignored the related problems. And it was the related problems that sank the ship. It was the related problems that caused the implementation to be incredibly painful, or I had to go copy the same protection code in 9 or 10 different places because I didn't solve the related problem in an elegant and simple way. And then the last question, it's actually 2 parts that you need to ask yourself when you're trying to identify these core patterns to a solution. What patterns solve the problems I'm dealing with? Now, if I'm specifically talking about system level concurrency, there's some patterns there. There's eventual consistency, there's first in wins, last in wins, pessimistic concurrency. There's different ways to solve it. What are the side effects of that solution? And so as I'm constructing this mental model, I'm able to create an idea for, let me grab another piece of information right here. Okay. There we go. And all right. So now I'm going to use my impersonation whiteboard here. And let's say I've now identified the middle problem, and that's my bank account, right? That is new account creation. Now, with my new account creation, I've identified some related things. I've identified that right over here, we've got concurrency. We've probably got some stuff down here over interrupts, long-running processes. Okay, and then right over here, let's say data correlation. My spelling's horrible. And so as I go through here and identify each of these problem spaces, I notice, okay, so now let's look at potential solutions. Now concurrency, I've got pessimistic concurrency. I've got last in wins, first in win. Okay, so I also have the ability to, let's say, order the processing of if I get an edit before I get a create, the edit gets ignored until I get a create, which means it could get ignored forever. Now, all right, so let's take a look at pessimistic. And we start creating this mind map around, all right, so if I look at pessimistic, some of the challenges with this are it's user entry intensive. If I have pessimistic concurrency, my user is required at any time there's a conflict to come in and correct the conflict, even if the conflict could be auto-resolved. Give you an example. I create a new account. I make an edit that changes the name on the account because it was misspelled, and I make a deposit to that account, both of which are edits. Now, if I say, hey, user, or hey, admin, who's responsible for curating this, you now have to fix this because there were two changes that happened within the same minute. But they're two unrelated changes. They could just happen. That's okay. My users get kind of perturbed with me. And we could try and get pretty smart. And there's some great merging algorithms and those kind of things for graphs of data. There's, interestingly enough, some software that is built entirely to change this problem into an easier to solve one. Things like correspondence framework and those kind of things. But pessimistic concurrency is very user entry intensive, and it ends up surfacing errors to the user pretty nasty, right? Hey, I'm editing this account, and then a user goes in to check their account and it goes, this account's locked for editing. QuickBooks Online, if you've ever used QuickBooks Online to run a small business or shared it with another person for the personal version of it, when somebody's in an area for editing, it actually locks that whole area. So I can't look up somebody's time off balance or their hire date if somebody else is even in that same area. That's pessimistic concurrency. It assumes a whole lot of problems. It guarantees that you're going to avoid issues, but your users pretty much hate it. And so we have a bad user experience. Now, does that mean that it's not the right solution for us? No, those might be the better answers. Give you an example. What if you're editing payroll for a company? Do you want two people making changes at the same time? No, you kind of want to lock that area down. So QuickBooks did. That's the choice they took because it was better than the alternative, which was to have to either write a lot of error correction software or potentially pay people wrong. Now, let's take in last in wins. Now, this one's pretty easy to code, right? So it's kind of easy to implement, which is a big thing, right? That's awesome. It allows the developers that are working with you to have a very clear understanding of it. But it is unfortunately opaque to the user. Now imagine you've got two users and they submit an edit and it redirects to the view screen, and they submit an edit at the same time and it redirects to the view screen. One of the users sees what they wanted to see. They are the last in, right? And then the other user feels like their change got ignored because it actually got applied and then overwritten. And so they end up seeing this view screen that looks like a wholly different change happened that they didn't ask for, right? And so you end up with these kind of odd, weird things. We used to call them Heisenberg bugs. The bugs that could never be reproduced were often caused by things like last in wins or merging of graphs that were opaque to the user. So the user would submit a bug or they'd call customer support because they didn't understand what was actually happening, when in actuality, it was a design choice that we made. Now, we could order the processing. Now, if we order the processing, we limit the system throughput. We also make it more difficult to add to the system. Because if I change my, go ahead and move this text box a little. If I changed my my ordering to that, I then have to go update the place that does the process ordering. Now I could do that through message IDs or Saga keys or those kind of things. But really what I'm looking at is changing the way a system operates and optimizing for consistency of process rather than optimizing for throughput or for latency, those kind of things. All of these can be the right decision if the downsides don't matter to you. Now imagine if you're writing a system that's going to do a very simple thing, it doesn't need to do a lot of it, and you don't want to worry about concurrency. You would choose ordering processing over last in wins or pessimistic concurrency, primarily because it would allow you to optimize the solution to your problem space. And if it's going to do a fairly simple set of things, give you an example, one of our clients years back had a system that just needed to take data from here and for each record, put a record on a message bus over there. And so what we did was we literally wrote a parser or a processor that looked at the insert or modified date in the database, and for anything that was in the last hour, packaged it up and created messages. That's all it did. And it processed every hour on the hour, and it stored in a text file the last time it was run. Now there's a ton of better ways that we could have done that. We could have had a processed flag on each record. We could have had error and retry. We could have created a database table to create the storage so that we could have multiple of these processors running that said, hey, here's the records that have already been done. We could have done a lot of those things, but we needed to process a ton of records very quickly. It needed to run only if the other systems were up, which meant that we actually put that process on the app server that ran the other systems, because if it went down, we knew that it wouldn't try and process records for the other systems. And we were able to very, very rapidly, in less than 2 weeks, solve the problem. And the speed to market was the primary concern of the system. And so we had to match the patterns we were using to the problem space that things existed in. And so what this ends up creating is a question for all of us to answer as we go through design, which is, does our problem space really live well with the problems and the patterns we're using to solve it? And what are their side effects? Now, I ask what are their side effects primarily for identifying what kind of debt I'm taking on. We've all heard the term technical debt. We've probably all used the term technical debt. I love the analogy though, because ultimately there are good and bad kinds of debt, right? If you're able to, let's say, buy a house, you could either pay cash or you could get a really low interest 30-year fixed mortgage. The 30-year mortgage sometimes makes financial sense. It's better for you financially to take on that debt. But then there's some debt that's dangerous, that grinds you to a halt and is tough, right? And that's like high interest title loan, payday advance, card, loan shark kind of debt. Now that debt you want to avoid at all cost. But in software, identifying which kind of debt you have is incredibly difficult unless you start looking at the side effects of the debt you're gaining. Because I have yet to write perfect software. The day that I find somebody that can write perfect software, it's going to be a happy day for me because I'm going to learn everything I can from them. But some of the best software developers I've ever met actually have the ability to write the right software for a client based on what the client needs and how their problem space will present. And so when you look at ultimately trying to match up the people writing the software being written, and the future state of what that software needs, you get into this interesting space where you're choosing which problems you want to have. And if I'm going to be choosing my problems, I want to choose the problems that cost me the least pain in the future. And that's going to vary system to system, solution to solution. So that's why that side effects question is so incredibly important. So as we move on and we take a look at these different pieces, we want to make sure that we're driving into that kind of low interest 30-year mortgage kind of debt. So if we were to take the problem space of object relational mapping, this is the space that Hibernate and InHibernate and JPA and Active Record and a few others all over the place try to solve. Entity Framework, Link to SQL, they all try and solve this. Now, if we were to try and come up with some of those core patterns, the core patterns that really are used to solve this problem, we end up with some interesting kind of questions. So let's dig into those. Now, what are the problems that we're trying to solve? We're trying to track records in a database and present them back into objects, right? And so we're going to need some way for mapping records to objects. We're going to need some way to track changes. We're going to need an interface to interact with, right? We're also going to need to be able to deal with different databases, right? We're going to need to be able to generate PL SQL when I'm talking to Oracle, or SQL when I'm talking to SQL Server, or Postgres, or Firebase, or Cassandra, or Mongo, or whatever. And so we're going to need to talk to different relational database management systems. I say relational because when you get into document, this whole problem space kind of gets either much bigger or much smaller, depending on how you want to interact with it. Okay, so what other problems might we have with dealing with the creation of an ORM? We're going to need some kind of query syntax, or potentially an interface to do querying against. If I'm going with like an example case of a like super easy to use thing like oak or dapper or massive, this is very SQL-esque and potentially is just hard-coded SQL. But then you end up with parameterization issues, those kind of things. If, however, I'm going with something that is more kind of integrated procedural, I may end up with something like language integrated query or LINQ, which we'll talk about here in a little bit. And so these are kind of the primary problems that an ORM is trying to solve. Now, if I was to sit down and think about this one for quite some time, which I have, I could come down to what I believe are like the four correct patterns for this. And so let's talk about them. Now, do I know what the objects I'm going to be mapping are? I don't, right? Which means I need the ability to mutate the algorithm that maps the records and objects based on some either design time or runtime input that's outside of my framework. Okay, there's a couple of patterns. There's template method, there's chain of custody, there's decoration, but strategy pattern gives me the ability to define how something's going to happen without defining the exact nuts and bolts of it all. I'm going to apply this mapping between this record and this object. I can define each of those pieces separately, and the strategy to combine them doesn't change. Okay, so that gives me kind of one of those potentials. What about talking to different DBMSs? Now, I could write a giant switch statement. I love switch statements. They're amazing. They're, oh man, that is, I can't make it through that sentence. I hate switch statements with a passion of 1,000 suns in my life. However, what I have found is that when we start trending down that road of tons of different DBMSs and those kind of things, there's some common patterns that start cropping up. One of them is the provider pattern, in which I have a provider and typically it's paired with an adapter because the interface to function against is an adapter. Now, if I want to talk to Oracle, I can ask for the Oracle translator, the Oracle provider for my query interface. If I want to talk to SQL, I can talk to, and go, hey, give me a SQL provider. And ultimately, as long as I've got the interface correct, as long as I've got my adapter in place correctly, the provider can deal with the interface's underlying pieces without having to change the consumption experience. And this is ultimately what language integrated query actually does for you, is it allows you a common adapter provider. Interestingly enough, just through the Q&A just now, Claudio threw out a switch statements die. I could not agree more. If I didn't end up using them because I'm not smart enough to come up with a different pattern, I would totally say remove them from C#. When I get smarter, we're going to try and remove them from C# though. Now, there is another piece to this, right? If I want to track changes and I want a query syntax that allows me to go grab stuff from the database, bring it in, and then change it and keep track of all of that, I need to control the construction of the object because I need to hydrate it from the database. At the same time, I need to inject little pieces of tracking code inside there so that I can see when a property is changed or those kind of things. So I need to be able to do things like iNotify property change. I need to be able to analyze the hash code to mark an object as dirty so that I can go reflect over it. Like there's a ton of different ways to solve it if I control the creation of the object. So we get into creational control patterns. You get into builders and prototypers, and that's right, factory. So at the core of the tracking problem is factory. Now, when I query something back and I provide that data, this is where factory is going to plug in. And so if I look and I go, all right, so the core big problems of this space, how do I solve those? You'll notice I've come down to 4 kind of interlocking and very tightly coupled patterns. And so let me switch back over to PowerPoint for a minute, because this is my place where I Martha Stewart this, and I go, oh, look, PowerPoint, there's a slide that has those same 4 patterns. And everybody claps, and then we all have cookies, right? Unfortunately, this isn't a baking show. So now we've talked about how we get here through thought process, through analysis of a problem. But what happens if we get it wrong? And let's say not like a lot wrong. Let's say we get 75% of it correct and we only miss 1 pattern. Unfortunately, I have a great example of this from the .NET space. So Microsoft at a certain point had 2 competing products being developed at the same time. One of them developed by the SQL Server team. One of them developed outside of that. One was called Link to SQL. The other was called Entity Framework. Now the Link to SQL team, because they were the SQL Server team, didn't really prioritize the ability to talk to a different database into their backlog. The Entity Framework team did. And so Entity Framework recognized that provider was a core pattern to their design. The ability to swap out the translation layer to different databases was going to be eminently powerful to them. And so when Link to SQL and Entity Framework were competing against each other, even though they were both Microsoft products, Link to SQL got traction faster in the Microsoft community and actually had features that it took years for Entity Framework to get to. But then Entity Framework was able to expand past the pure Microsoft stack shops. They were able to talk to Oracle. They actually created a vendor ecosystem where there were companies that sold data providers to different databases that plugged into Entity Framework. And which one of them survived to today? Link to SQL's shelf life was shorter than that of Silverlight. And Entity Framework still going today and moving more and more towards the swappable pieces, configurable in the .NET Core space. And so by missing 1 out of those 4 patterns, Link to SQL signed its own death warrant, simply for the fact that it was less adaptable of a solution because they missed a core problem and a core solution. They solved it a different way. So now let's move on. Let's look at another big problem space. What about language integrated query? Right? Language integrated queries got some big, kind of fairly nasty problems when you start thinking about it. I want the ability to defer execution. I want the ability to compose queries. I want runtime variables to queries. I want a domain-specific language based on my data, right? And I want a common interface for all data in memory or provided. Those are some hairy problems. Like those are some impressive problems. But what would we do to solve them? Now we've talked about the ability to kind of build up and kind of tie together different execution paths, right? We've got some strategy in there. Let me line this up better. My OCD is taking over at the moment. There we go. Right. We've got strategy pattern, and that is going to give us the ability to kind of pull those things together, but it's not enough. So my strategy pattern needs to be composed with decorator. Because not only do I need to be able to build up strategies, oh, thank you, by the way, somebody who just told me that I was sharing the wrong screen. That's fantastic. You saved me from going on for a half an hour before somebody realized that. And so strategy pattern, we need to combine it with decorator to really get those composable, those queries. But hey, guess what? Decorator also gives me control of the execution pipeline. And so I can defer execution of the decorated stack. Oh, hey, guess what that does? That also gives me the ability to control when runtime variables are injected into an execution object. Now, if I've got my DSL, right, there's some command pattern in there. Now, so we've got strategy, we've got decorator, we've got commands, and we've got query object, which is, interestingly enough, a combinational pattern that actually brings together strategy, command in a pretty unique way. And so if I look at these, I go, okay, awesome. Now, language integrated query has been tried in a lot of different languages, but nowhere has it been more prevalently adopted than in the .NET space. And one of the reasons for this is the elegance of it. If it's in memory, it's still deferred, it's still composable, and it's the same interaction style. I've got a DSL where I go list dot, well, why am I talking it through? I've got DSLs easily that I can go list dot where for each object, when the name of that object contains an A, and that will filter my list, whether it's in memory, whether it's in SQL, doesn't matter. And then I can go, I want to page that data by taking the first 100 records. I want to, let's say I want to order that data. I want to order it by the name of each object. And I can do this regardless of whether this list is living in SQL Server somewhere, living in Oracle, living in Cassandra or Mongo or Hibernate or Raven. It really doesn't matter where it lives because language integrated query allowed for a DSL independent of data provider. Now, interestingly enough, there's a nice little trivia question. When I run this, let's say list is actually an entity framework queryable. Does this code ever get executed? I've got my decoration as it composed. I've got my strategy. I've got my DSLs that it's procedurally making these commands. But is the resulting query object ever actually executed? No. It's only executed if that's in memory. The resulting object simply gives the SQL translator something to traverse over and translate into a SQL statement. This code's never even executed. And so you get this interesting interplay between these design patterns that allows you to create expression trees. Oh, sure. I can zoom. And I might even be able to pan. There we go. And so by doing this, the .NET team and the link to so the link that was released in .NET 3.5 SP1 actually redefined the way we interact with data in a system. Now that has caused all sorts of downstream coolness and terribleness. The coolness is, to Claudio's point, we can also use bits where it enables type interfaces, generics, lambdas, etc. That allows you to drive this through, and you end up avoiding a whole lot of covariance and contravariance problems because it's impeccably well built. But because it's impeccably well built, a whole lot of people look at this nice big bubble right here. Let me make sure I've got my pen, my brush. So this nice big yellow bubble. A whole lot of people look at this and they don't realize that they're hard coding SQL statements somewhere. Because that is a SQL statement. Regardless of whether it looks like SQL. I don't say select star from table, but that's what that is. And so how many times have we, because this is so easy, because it's implemented well, we then put this in the controller, or we put this inside a view, or we put this in a hydrator inside a screen. And so the fact that this was so well built and so easy to consume actually gave us a new pattern that we had to deal with in the architectural layers, in other applications, in other related code bases. And so it really led us to this great place where we realized that a well-built problem, or a well-built solution to a big problem, because I remember the days before object-related relational mappers and language integrated query, where I would spend weeks and months writing data access layers that were simply going to be used by business logic. And so by doing this, I no longer have to do that. I can get straight into the business logic. I can get into what produces value for the business. But unfortunately, what that means is I'm so much faster, I may have lost some of that nuance. Yesterday's problems are why we create today's solutions. And today's solutions create tomorrow's problems. So architecture is going to evolve. It's going to get better or worse over time, guaranteed. And so as we look forward, we have to look at the levels of technical debt that we're willing to carry, which brings us back to where we started, which is how do we evaluate that debt? As we progress, we want that low interest, fixed rate technical debt. What differentiates those? The big differentiator for me personally, as I look at the different patterns that are in play in architecture, is does it violate one of the core patterns? If I want to add, let's say, a key value store that determines change tracking, or I want to add a hashing algorithm inside my object relational mapper, I look at it against the 4 key patterns and go, yes, it's in line with all of those. It's probably low interest technical debt at that point. But what if it violates it? What if you create the easy turn, the corner where you don't really have to do something? You give yourself the escape hatch that allows everybody to violate the architecture. That's where you get into the payday loan, title loan kind of debt. the debt that snowballs to the point where at some point in your future, a consultant's going to walk in and go, we got to rewrite it. It's those pieces. Now, how can you tell? It's typically the ones that give you that sinking feeling in your stomach and you go, that's not really what we intended, but yes, you can do that. Or when you ask them about it, you're like, hey, but isn't this a pattern you don't want to drive? And they go, but it works. Those are typically the places it lands. Assad's question just came up. It says, seems like we would need a kind of dependency injection to make sure that the common interface for data is implemented. So ultimately, yes, that's where provider plays into it in the object relational mapper. So language integrated query actually has what's called a query provider. And that query provider is only required when you want to touch on something that's outside of in-memory data processing. And so when Entity Framework uses language integrated query, its provider is what actually interacts with language integrated query. And that's why the provider pattern is a core construct in the object relational mapper and a complementary construct in language integrated query. Hopefully that answered the question well, Assad. So if you want to follow up, you want to talk through some of these pieces. We've been going for about 50 minutes, 45 minutes. I do want to open up some additional questions in the Q&A. I've got a couple of them that I'm going to go through in here and answer in a minute, so feel free to kind of preload some in there. If you want to follow up, please, wow, I put my old really long email in here. Let me fix that real quick because I can save you 11 characters of typing by the fact that years ago, we removed the enterprises from our email addresses, but apparently the slides I was moving around today had the old email address in it. There we go. All right. Whoa. Happy days. There we go. And so if you want to follow up, you want to talk about how this may apply inside your application, those kind of things, feel free, please reach out to me via email. I nerd out on this. And if something like this, you're like, I need my digital technical growth fix. And with the user groups and conferences, not all of them are meeting. We're incredibly lucky that Assad is still pushing this forward. And I say, Assad, thank you, man. You are doing some great stuff for the community. We're lucky he's pushing that forward because a lot of user groups have just kind of held up their hands, thrown in the towel and said, we're going to wait this out and we'll meet when it comes back. But that leaves a lot of us with a hunt for that growth content that we'd typically get in a user group. Feel free to hit up the virtual events page. We've got a bunch of stuff coming in there. I know Assad's going to be keeping this running and digital and virtual. Next time, I promise I will do some better prep and make sure that Assad can get in here and talk to you guys. That's on me, not on him. So one of the questions is, what happens if you misidentify the 4? You don't miss one, but you get one wrong. If you get one wrong, then it comes down to how well you implemented it, because there's a big difference between vision and execution. Now, vision without execution is hallucination, and executing without a vision is chaos. But let's say that you had a vision and you executed it very well. You isolated concerns, you separated into modules, you had good domain-driven design. If you realize later on that you got one of the patterns wrong, it's much, much easier to change the core design tenets if the system is well built. But if a system is poorly built, but you got the core design tenets correct, it can last a very, very long time. So you only really run into the big problem when you have a poorly built system and got the design tenets wrong, in which case it's going to hurt to modify. It's going to be pretty terrible actually to modify. But what you can do in that case is when you're modifying it, try and make sure that you get it better the next time. By better the next time, I mean apply behavior-driven development, use acceptance test-driven development, or start wrapping up your business design in Gherkin statements and operational testing, those kind of things, because that'll actually drive to a better architecture simply because the architecture will be verifiable, independent of its implementation. Now, if that's something that you're really like, oh, that sounds amazing and I want to do that, have Assad reach out to Claudio, because Claudio is the expert I know and rely on for this very thing. Awesome. Well, it seems like that is just about all the questions we have in the QA. I greatly appreciate everybody taking some time from your evening. I know time with family is a precious thing. Thank you for spending time. Assad obviously will be setting up some more of these and communicating that out. Again, I promise we'll get the technology better next time. Thank you all. Have a great evening. And if you got any questions, feel free to hit me up. Have a good night.